Welcome back. Let's discuss how we can go about proving that triangles are congruent. We know that if all three angles have a corresponding group of angles in another triangle that are congruent, and all three sides have the same thing in the other triangle, then we know they're congruent. But is it possible to prove they're congruent with less information than that? Well, it turns out that there are 5 valid ways to prove triangles congruent. And then there are 2 ways that many people think, at least at first, that they would prove it, but they don't. These are invalid proofs, and we'll look at those briefly in just a moment. So first off, now our instructions. Based on each given diagram, write a correct congruent statement and the postulate or theorem that applies. Now these postulates or theorems, I've got the abbreviations here. I'll go ahead and read out what they mean. Side, 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 angle, 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 side, and hypotenuse, leg. These 2 that don't work are angle, 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 and side, side, angle. So looking at these pairs, this pair on the left, I guess we could call this example number 1. We have 3 sides in each that are marked. We've got 1 mark that matches this 1 mark, 2 and 2, 3 and 3, and we have 3 sides in each that match up. So these are congruent by side, side, side. Now we could have had names to these points, and if that was the case, that's perfectly fine. You could have your triangles named, and you would say that it would write something or read something like this: triangle ABC is congruent to triangle DEF by side, side, side. Now, for now, we're just going to name it. We don't always have to write the congruent statement. I guess I can. The instructions said to do that, but the main thing is identifying side, side, side. As we go to the second one, and I guess I should go ahead and name these. Let's put some letters in place. It doesn't really matter for us too much, but we have some of the information given. You notice we don't have this third side. We don't have these 2 angles. But what we do have is these 2 sides matching these 2 sides. And then we have the angle where they come together. That's called the included angle. And it has the same marking as this included angle. This second one that we were looking at here has 2 sides with an angle in between, just like what we see in our diagram. So that's the reason that they're going to be congruent. When I name these, I don't really care how I choose the letters for the first one, but the order I choose them, I have to follow that over here. So I went A, B, C. That's along the side with no marking, along the side with 1 hatch mark. If I do that here, that would be H, G, J. And then by, side, angle, side. Our third example, and I'll put some names here again. We have 2 angles that match these 2 angles, and we also have the side in between them that's included, that has the same marking. So it's angle, side, angle, angle, side, angle. So triangle ABC is congruent to triangle what? Well, when I named this one, I went from the angle with 1 mark to the angle that doesn't have a mark to the angle with 2. If I do that here, that would be TSR. And the reason is angle, side, angle. Our fourth one, we can label parts of it again, and I'm putting ABC on the first one every time, and then just mixing up the letters over here. It doesn't really matter, but that's really up to you. On this one, I have an angle that matches, another angle that matches, and then I have a side that is not included. It is not between those two angles. So this is a non-included side, but as I go around this triangle, it's the next side that I see. Going from the 1 to 2 mark angles, it's the next one I see. That's the same way that this one is done. So it's the same non-included side, which is important. It has to be done that way to be able to use this theorem. Well, triangle ABC is congruent to triangle. I went from the angle with no mark to 1 to 2. No marks to 1 to 2 is WYX by, and this time, angle, angle, side. Even in the theorem, the side is not between the angles, so it matches what we see in the picture. Now, this is not a new one here, but I just want you to be aware that these triangles don't always have to be separate. In this example, they're connected. And sometimes you're only given some of the information, and you have to realize, for example, right here, that these are vertical angles, and so they would be the same. And that gives you enough information then to use one of your theorems to prove that they're congruent. In this case, it would be angle, angle, side again. Our fifth example is two triangles, and they are right triangles. If they're right triangles, then you're looking for the legs to be congruent or the hypotenuse to be congruent. The angle across, or the side across from the right angle, is the hypotenuse, and in each of these that's the same marking. Then one of the other sides, these are legs here, so this leg is congruent to this leg, and that's all you need. These are congruent by hypotenuse leg. What's going on in hypotenuse leg is that since the Pythagorean theorem holds true for right triangles, these values, if they're the same, they would produce the same third side value, and that would mean that we would actually have side, side, side. So that's what's really working in the background of this. Even though we're using hypotenuse leg, side, side, side really is what's at work. Well, we could label these and name the triangles, but I'm not going to do that here. I'll just move on. At the bottom, we have two examples that seem like they might work, but here's evidence that they don't. These two triangles have three sides with marking. So the way I have it, these are equilateral triangles, and because of that, they're equiangular triangles. They have 60-degree angles. It's pretty easy to see here that even though they have the same shape, all their angles are the same, they're clearly not congruent triangles because the one on the left is much smaller than the one on the right. So angle, angle, angle does not work. Okay, I'm going to cross it out. It is not a valid way to prove triangles are congruent. It doesn't mean that if they have the same angles that they aren't congruent. All it means is you cannot prove that they're congruent just because you have all the angles with matches. Well, that's also true in this second one. Here I have a triangle on the left, and I will put some letters on this one. Triangle ABC on the left has a side with one mark, a side with two, and then this non-included angle. The big triangle, triangle ABD, has a side with one mark, a side with two, and a non-included angle right here, the same one. These are definitely not the same size triangles. This, I'll mark it like this. This triangle over here is not nearly the size of the big triangle ABD. So even though we have side, side, angle, side-side angle is not a valid way to prove triangles are congruent. See you next time.